Okay, this activity is called resistance roadblock. So what we're going to do here today is we're going to see how having a variable resistor along with in series with a light bulb, how it will affect the amount of current that is flowing through the light bulb. Okay, so this device over here is the rheostat, kind of tube with wire wrapped around it. Okay, so the wire that goes around that is nichrome wire. Okay. And so as I move the slider on that, I can go anywhere from having no resistance, okay, to having the full resistance of the coil. So it's just by moving this slider, which is right here, I can move this along the length of the rheostat, and I can adjust my resistance to different values, okay. So as I slide it along, so at the left end, no resistance. If I slide it all the way, yikes, to the right end like that, now it's got the full resistance of the coil, okay, which as it stamped right on that rheostat, it's 11 ohms is the full resistance of that, okay. So that would be in series with the light bulb, which is right there, okay. So we're going to see what effect that has on the current as I move that slider to different positions and add resistance to the circuit, okay. So we're trying to see what that's going to do. So first thing we got to do is make a prediction. Okay, so here's the circuit diagram. So you'll want to copy that down, okay, under apparatus, okay, for resistance roadblock. Now I'm going to move to the next page here. That's our data table. So where it says current predicted, you're going to want to predict, okay, is the current, do you think it's going to start low and get high, or is it going to start high and get low, okay? So as I move that slider and increase the resistance in the circuit, okay? So you're either going to say for A, low or high, right? And for C, the opposite, right? So it's either going to go low, medium, high, or high, medium, low. So you got to pick, okay? Now, for bulb brightness, okay, the amount of current should go hand in hand with how bright the bulb gets. So predicted, you're either going to go dimmest, medium, and brightest, okay, or you're going to go brightest, medium, and dimmest, okay. So that's what you got to pick between. What do you think is going to happen to the current? Is it going to get higher as you go, or lower, okay? And with the bulb brightness, is it going to get brighter as you go, or is it going to get dimmer, okay? So that's what you got to do. So make your predictions, write that down, and then we'll actually see what actually happens. Okay, so now we're going to do the actual experiment. First of all, Bella is going to close the knife switch to allow current to flow, and we'll see what happens to the light bulb. Okay, so you can see that light bulb is pretty bright. There's 0.32 amps of current flowing through, okay? And what we want to observe here is what happens to the brightness of that bulb and to the current as she moves the slider from the position where there's no resistance of that coil. It's not flowing through any of it at the moment, okay? Now we want to get it to flow through about half of the coil, about half the wire. So Bella's going to move the slider over halfway right now. Okay, good. Now, so note what happened to the brightness of the bulb as she did that, and also what happened to the current, okay? So the current dropped to 0.30 amps, okay? And hopefully you notice the bulb brightness got a little bit dimmer, okay? Now she's going to move it all the way across, and again, observe there, okay, there. I think you definitely could see a dimming of the bulb as she moved it to the full position, right? And the current dropped to 0.28 amps, okay? So as resistance is added to the circuit, okay, the bulb brightness goes down and the current goes down, okay? So now we're just going to record this in our data table. Okay, and here is the data table that shows what happened in the experiment. So in position A, where it wasn't going through the rheostat at all, okay, or the nichrome wire, 0.32 amps, and it was brightest. The bulb was the brightest at that point. Position B was when the rheostat was put in the middle position, so it goes through half the coil. The current was 0.30 amps, and it was kind of medium brightness. And finally in position C, where the current goes through the whole coil of the rheostat, okay, adding the most resistance to the circuit, the current dropped to 0.28 amps, and the bulb was the dimmest. Okay. So now you'll be able to flip that sheet over and answer the questions on the back. Thank you.